We did not quite finish goal 1, so let's finish that now. As the last screencast ended, we were finding n above r, or the binomial coefficients, using our calculators in combinations of r. And so we get that 3 above 0 is equal to 1. I would like you to pause the screencast and calculate the binomial coefficients for 3 through 7, and then turn it back on and check. All right, so you should have binomial coefficients with 84, 1, 28, 1, and 1. And I want you to notice every time r is 0, you have a coefficient of 1. Well, anytime r is 0, remember, that's when our second term was raised to the 0 power. Also, I want you to notice anytime that n and r are equivalent, as in 4 and 7, the binomial coefficient is 1. And that matches up with the power of expansion is 6, so the last term is raised to the 6th power. Binomial expansion is 5, the last term is raised to the 5th power. So when r is 0, that gives you the leading coefficient of the expansion, or the coefficient of the first term, and when r is equal to the power of expansion, you are now at the coefficient of the last term. Okay, so let's use these things and expand these coefficients, these binomials. So here we have x plus 2 raised to the 4th power. So our first term is x, and our second term is 2. So I'm going to begin by expanding x plus 2, then I will go back and place the coefficients. I know that the first term is always raised to the power of expansion, so x to the 4th, plus I will leave a space for my coefficient. Now I have the first term to the decreasing power, and the second term is now to the first power, plus my coefficient, now x to the second as we continue to decrease, and 2 times 2 to the second, plus my coefficient, my binomial coefficient, x to the first times 2 to the third, plus my binomial coefficient, x to the 0, which is 1, no need to write that, and then times 2 to the 4th. Okay, let's go back and put our coefficients in here. We know that the first coefficient is 1, the last coefficient is 1. We know that the second coefficient is always the power of expansion. We know that the next to last coefficient is also the power of expansion. So we've got it pretty easy here. It should be very simple to find n above r. We know that n is 4, and we know that r is always matches the power of the second term, so 4 above 2. So take a moment on your calculators and calculate 4 above 2. And that gives me a coefficient of 6. So this coefficient is 6. Now from here, I would expect you to go back and multiply and simplify completely. So 1x to the 4th, plus, remember to follow order of operations, 4 times 2 is 8x to the 3rd, plus 2 squared is 4, 4 times 6 is 24, x to the 2nd, plus 2 to the 3rd is 8, 8 times 4 is 32x, and then finally 2 to the 4th power is 16. And I'm going to go back through and check. I have no like terms to be added or subtracted. And we have successfully expanded x plus 2 to the 4th power. Let's look at example number 2, x minus 1 to the 3rd power. When we expand, this time we'll have to consider the negative in front of the 1. When you expand the second term, that minus goes with it. So we know we have x to the third plus the leading coefficient, or I'm sorry, the binomial coefficient of the second term times x, that was a horrible x, times x to the second times negative 1 to the first, plus the binomial coefficient, x to the first times negative 1 to the second, plus the binomial coefficient times x to the 0 times negative 1 to the third. So we started with the third power for x and decreased by 1. We started with the 0 power for negative 1 and increased by 1. Let's go back and place our coefficients. 1, the power of expansion is 3. The first x coefficient is 1, the last coefficient is 1. The second is 3, and the next to last is 3. So in this case, we did not need n above r at all. So let's clean this up. 1 times x cubed is x cubed. Here I have 3 times negative 1 to the first. So that's 3 times negative 1, so minus 3x squared. Negative 1 squared is a positive 1, so the third term is plus 3x. And then the last term, negative 1 to the third, is a negative. And let's double check. Remember, we should always have one additional term or one more term than the power of expansion, and we do. I'd like you to expand number 3 and then pause the screencast and check your expansion before you start to multiply within each individual term. Okay, let's take a look at your initial expansion. You should have the first term to the 4th power plus the first term to the third, first term to the second, first term to the first term to the 0. Then the second term should be to the 0 power. That's why we don't see it here. Then negative 3 to the first, negative 3 to the second, negative 3 to the third, and negative 3 to the fourth. And then I went back in and placed my coefficients in red. And if you don't want to place the coefficients of 1, that's not necessary. And then we have a coefficient of 4 as the second in the next to last term, and that's because the power of expansion was 4. And then the third term was the only one we did not know. Remember, it's n above r, or the power of expansion, and then r is the power of the second term. We already know that from calculating previously in example 1 that this is 6. Now, this is where students start to make mistakes in the simple math. So please be very careful as you go through and simplify each term. This is not 2 to the first. This is 2 to the first raised to the 4th power. You know that 2 to the 4th power is 16 times x to the 4th power plus negative 3 times 2 to the 3rd power. Following order of operations, 2 to the 3rd power is 8. And then you have 8 times negative 3 times 4. So be very careful about that. So this is 4 times 8 is 32, and 32 times negative 3 is negative 96. So we should change this to negative 96. X to the 3rd power. The next term will be plus, and here we have again, we have 2 is being squared, and the negative 3 is being squared. So 6 times 4 times 9 is 216. X to the 2nd power. The next term, we have a negative to an odd power, so I know this is going to be negative. 3 to the 3rd power, or negative 3 to the 3rd power, is negative 27 times 2 times 4 is negative 216 x to the 1st. Then finally, our last term is a negative raised to an even power, so plus 3 to the 4th power, which is 81. Okay, so now I want you to take number 4, expand, simplify completely, then come back and check your answer. So our final answer is 16x to the fourth minus 32x to the third y plus 24x squared y squared minus 8xy cubed plus y to the fourth. And I hope you caught the fact that when you have a binomial where the second term is being subtracted, the sign's going to oscillate back and forth. Plus, minus, plus, minus, plus. The same thing here, plus, minus, plus, minus, plus. I hope that helps you speed up the process just a little bit more.